Hello friends, welcome back to my channel. Today I'm gonna show you how we can do rainfall erosivity factor to compute RUSLE model. In the previous video I have shown you the general overview of RUSLE model, the input parameters that help us to compute RUSLE, and the general flowchart. As you know, RUSLE model is a byproduct of rainfall erosivity factor, soil erodibility factor, LS factor that is related to the topographic structure, slope length and slope steepness. The other parameter is C factor or cover management, and P indicates for conservation practice. So by computing all those input parameters we can easily estimate soil loss. This is the general flowchart of RUSLE model. So today, as I mentioned earlier, I will give you special emphasis how to compute rainfall erosivity factor using station data. Let's go. For the sake of this exercise, I would like to define what does mean rainfall erosivity factor is. As you know, rainfall erosivity is defined as the potential ability of rain to cause erosion and give us the product of the total energy of rainstorm and the maximum 30-minute intensity. This indicates that both the amount of rainfall that receives in a certain area and the intensity of rainfall have a kinetic energy to detach soils. For this exercise, I would like to use the empirical formula which is developed by Hurni-Hans in 1984 for the highlands of Ethiopia, which is estimated R value by using 0.562 times mean annual rainfall of our study area minus 8.12. This is a general formula that helps us to compute rainfall erosivity in the highlands of Ethiopia. This is my Excel data. I have 12 meteorological stations with long-term average rainfall. This is the latitudinal and longitudinal position of each station. The mean annual rainfall for each station is recorded here, and I would like to compute R factor using Excel. By the way, we can also compute R factor by using raster calculator using MapAlgebra in a spatial analysis tool in ArcGIS. Let me show you the first mechanism. To compute R factor, we use this formula. So what we are going to do is make it is equal to open bracket 0.562, this is a constant number, times P stands for long-term average rainfall. This is mean annual rainfall. Let me use this column, select this and close the bracket, minus the constant number is 8.12. Hit enter. So the rainfall erosivity or R factor for Kobo station is estimated this much. Within the same fashion, we need to compute all stations. So double click here and automatically we can generate R factor for each station. After having this, let me remove this formula and save it in CSV file format. Then to gain rainfall erosivity raster map, we need to open ArcMap. So what we are going to do is we need to add our Excel data. You can enter by add data or you can use your R catalog. Let me open my R catalog, and this is my working directory or folder. Open, then I have this rainfall the Excel data. The other is I would like to add my area of interest or my study area. The first step is we need to convert this CSV file format to shapefile. To perform that, let me go to the CSV file format, right click, display XY data. X field is longitude, Y field is latitude, Z field you can set if you have any elevation or any other parameter. The most fundamental component here is we are expected to set our coordinate references. To do that, first we need to explore the Excel data. This indicates that the decimal degree, so this is geographic coordinate system. Therefore, what we are going to do is go to edit. From edit we have geographic and projected coordinate system, and my data is recorded in geographic coordinate system. So hit the plus sign, select world. From world we need to WGS 1984. Make it OK, hit OK. This is all the pointers are the station, the 12 station that is recorded around my area of interest to gain raster dataset via interpolation. So this is CSV event, and we need to go to one further step to gain a shapefile of each station. Right click here, go to data, then export data. So set your working directory and rename it as station. Let me say station data. So save it. Okay. Do you want to export data as a map layer? Yes, I need a layer as a layer. You can increase the size of the pointers for visualization purpose. And let me remove CSV file format and the CSV or the Excel data. All these pointers in green are the meteorological station which is around my study area, and based on this I would like to create a raster data set, and I would like to generate rainfall erosivity factor. To do that, go to Arc Toolbox. From Arc Toolbox select Spatial Analysis tool, and from Spatial Analysis tool let me select interpolation. As far as interpolation is concerned, we have three major kinds of interpolation. The first one is IDW, the second one is grading, and spline. All the three are most common, and I would like to use the IDW interpolation technique. So interpolation is generating raster data from point data. So the input point feature is a station. The Z value should be the R factor. So Z factor should be R factor. Let me set our working directory and let me rename it as RF rainfall erosivity factor. Save it. Leave it the output cell size as default. Go to the environment to clip out your output based on your geographic area or area of interest. So the processing extent should be the same as the shapefile. This is the extent of the shapefile, the top, bottom, left and right. The other is, let me also set raster analysis. From raster analysis I would like to select the mask layer, or the mask should be the same as the shapefile. Make it OK, and finally hit OK. After a while we will gain the rainfall erosivity factor map of my study area. Well done. So let me make halo. This is the rainfall erosivity factor of my study area. The color indicates that the eastern part of my study area have lower rainfall erosivity because it considers the amount of rainfall they receive and the intensity of rainfall. This is a border alongside of the DFR regional state. So this is all about rainfall erosivity factor. If you have any question, let me know. Have a nice day.